research it all. I didn't research the.
Alright guys, let's go over some details about Wavelet blockchain. There are some key factors that we'll try to understand here. So Wavelet blockchain follows partially synchronous network, and it guarantees two things: the total ordering of transactions and transaction irreversibility. So basically all nodes finalize and apply the same set of transactions in same order. That basically allows the consistency between the nodes, and once the transactions are committed, they cannot be cancelled or reversed. Right, and here is talking about the problems on proof of work and proof of stake. We know that proof of work follows longest chain rule, right, where miners wait for the longest chain, and they try to put the blocks on top of the longest chain. So this makes a proof of work very secure, but the slowest blockchain. And with regards to proof of stake, there will be election or random algorithm to choose the validators, which are the leader, who makes the decision which blocks goes to the blockchain, basically. So what happens here, if we have the small number of validators, then there is a possibility of fraudulent activities. And if we have large number of validators, then it will be sacrificed to the scalability, right? So basically, we need to compromise between security and scalability in terms of standard proof of stake algorithm. So Wavelet is coming with something a next level on this one. So they don't have any leader or election based system, right? Rather than they're using something called leaderless algorithm. So let's have a look at this. Here they are just explaining one analogy, like what does partial ordering transactions means, right? Is basically like, let's say you are depositing 500 into your account and then transferring that $500 to another account, right? The transactions order that you see is first deposit and then transfer, right? If you see first transfer and then deposit, it doesn't make sense actually, because otherwise you will have a minus 500 transaction, 500 balance in your account, which doesn't make sense. Anyway, guys, so let's go over this two most important processes in the Wavelet blockchain called gossiping and querying. So basically, gossiping, what it does is all nodes communicate with each other, right, to update information about transactions on their graphs. So as we know that the Wavelet blockchain follows the directed acyclic graph, right, as I mentioned ago. This gossiping process, where all nodes decide what kind of transactions and graphs have happened, basically, and tries to finalize these transactions and tries to come up with the same graphs on all the nodes, right? So but they are not doing any commits to the blockchain yet. They are just like kind of just communication is a gossiping. And that's where the querying comes into the picture, where nodes actually goes bit by bit in the nodes graph and try to understand and try to keep the consistency with other nodes. So this creates a problem called partial synchrony, right? When gossiping and querying are running at the same time. Why? Because gossiping is faster than the querying, because querying goes into the details and commit things into the blockchain. And the way Wavelet solves this problem is using the load factor, right? So the number of transactions that processed by the querying protocol gets automatically adjusted depending on the network load. So if a network load is very high, then the number of transactions processed by the querying protocol get increased, right? And to do these things, they have the design. Very two important factors in the design is overlay network protocol. For that, Wavelet blockchain is using something called Cademia. I think it's very popular nowadays. Like most recent blockchains that I have come across, they're all using this Cademia protocol. network protocol. In a nutshell, Catennia is a distributed hash table basically for peer-to-peer computer networks. So which is much quicker than conventional blockchain. It just uses order of log n nodes during the search. When you have like millions of nodes into the blockchain running the consensus algorithm, this will be like way faster than conventional blockchain. And for the querying protocol, they are following Snowball is something interesting concept here. So basically, what happens is the node exchange the information with other node, right? And they keep doing this if they see that this is a critical transaction that cannot be committed immediately. Then they keep exchanging these informations with other nodes, right? A number of times actually, which is predefined, and that's why they call that as a snowball snap sampling technique. Right? If we want to see snowball sampling technique algorithm, this white paper has it here. Yeah, so basically it kept going until it is decided and accepted the transaction, and this they do it only for critical transactions if they have any suspect, right? And the beta is here, you can see it's a predefined number that the number of times this transaction pass between the node has to be greater than beta before it accepts. It's something a unique concept that I have seen so far in the blockchain. Right, guys. So let's go over Wavelet staking and reward system, how it works. This is a little bit very complex. Okay, I hope I will be able to explain you guys. They have given a very good example how the staking and reward system works. So let's start with this Genesis transaction, right? So Genesis transaction goes on the level 0, right? And then let's say one person called Chad is coming. So he builds up the transaction on top of Genesis block. He comes on depth 1, right? And what happens is now let's say he's taking some Perlin tokens, so he becomes a validator here, right? And now another person, let's say Alice, is coming, and now she has an option whether she can build a transaction on top of Genesis block. Then she will stay with the chat on depth 1. If she can build a transaction on chat, then she will be on the depth 2, right? So let's say she built the transaction on the chat on top by referencing the chat transaction. Then what will happen is the transaction fees that Alice pays goes to chat because chat is a validator. So Alice didn't stake any polls, so she is not validator. But now let's say another person, the Bob, is coming, and Bob is referring the Alice transaction, right? So Bob is on the level 3. Okay, so he refers to the Alice transaction, and the transaction fees that Bob pays go to chat because Alice is not validator. Okay, and now Bob has also staked some Perlin tokens, so he becomes validator as well. So now we have a 2 validator, Bob and chat. Now let's say that Jason is coming on the depth 4. All right, so if Jason is referring the Bob's transaction at level depth 3, then what happens is the fees that Jason pays can go to Bob or Chad because they both are the validator, but the Chad is ancestor of Jason, right? Transaction fees reward goes to Bob or Chad. That depends on the algorithm, something called the reward system using a breadth first traversal. So let's see that. Right. So what they do, this system is something very interesting here. Let me find out. So yeah, they have given this example, but we don't need to go that example. Let's see. So basically, what it does is the algorithm manage something called threshold value that is always between 0 to 1. and that depends on the transaction hash. Basically is 2 to the power 16. They take choose the random value, right, and convert into the some checksum, and then let's say converted the value and it came to 0.4. It is always between 0 and 1. Then what happens is the graph traversal happens, right? It is basically the DAG. It's a direct to acyclic graph, right? And DAG, the traversal happens in a way is a breadth first traversal. Breadth first traversal in a nutshell, if the starting node is, let's say, JSON on the level 4, right? Then the next node that will be traversed depends on all the connected node to the JSON, basically. So all the nodes traverse that is connected to JSON, and then it go to the next depth. We will see one example also. It has given how this breadth first traversal work. But here, once that 0.4 threshold has been chosen, then what happens is it assigns some kind of range, right, to each validators in the whole graph, basically. So let's say this is different example, but doesn't matter, right? So let's say Larry has assigned 0 to 35, 35 to 85 goes to Nora, 0.85 to 0.9 to Tyson, and 0.9 to 1 is Emma. And this range assigned depending on how many tokens you are staking, right? So what happens here now, the 0.4, which was chosen randomly, is falls into Nora's range. So that's why she gets the reward. So it looks easy from this example, but when you think about the millions and millions of nodes, right, this goes crazy. But in a nutshell, the basic algorithm remains same. So the breadth first traversal algorithm, the way it works is represented here. You can see it's a directed cyclic graph, right? There is no, I mean, it's a direct, but there is no cycle in it, right? So if we start with the LX, the next node that gets traversed is either Clara or Kyle, right? So it depends on which node it will select. It's a weight. So like it's a 2 is Clara and 3 is Kyle. So Clara has a less weight than Kyle, so it will be visit the Clara, right? Then the Kyle, and then Clara has 2 nodes, Sally and Rohan, right? And the Sally has more weight than Rohan, so Rohan will be visited first, then Sally, then it goes back to Kayla. Kayla has a 2 child node, the Rohan and Katie, but Rohan is already been visited, so it will visit Katie. And now we are at Genesis block. So that's how the traversal happens, and during this traversal, it figures out which nodes are basically the validators, and depending on their stacking and the threshold value that is generated randomly, they get rewards.